Dear President of the jury, dear members of the jury, ladies and gentlemen, it's a great pleasure to today present my PhD thesis titled Scenario-Based Design of People-Centered Mobility Solutions for Urban Systems. Just a second. Pleasure to be here with you. I was at the title, so this is the title. Before I start talking about it, I want to take a little bit the time to talk about the different words which are in the title, because they will be words which we are using throughout the presentation. The first one is scenario, and scenarios we understand here as a set of multiple distinct possible and plausible future alternatives. You see an example from one of our application cases on the upper right. So when we talk about scenarios, we talk about future scenarios. Then the next one is design. Design, we are using the definition of Herbert Simon, is the process where we devise courses of action aimed at changing existing situations in preferred ones. The next one is people-centered. So this, I will talk more about it in detail later, but generally we define it as an approach which prioritizes people's needs today and tomorrow in the direct environment, but also further away. Mobility solutions refer to any kind of product, service, or policy which in some way tries to address one or several problems of an urban mobility system without necessarily solving them. So a solution just tries to address something which is there. And then finally, urban systems, or more precisely, urban mobility systems. We refer to a multi-scale discipline or a multidisciplinary complex adaptive socio-technical systems, which is defined more or less by the daily territories of people. So where do we move on a day-to-day basis? And then these people which we refer to, which are both the residents of an area, but also people who might come from elsewhere, tourists and so on, we refer to as urbanites throughout. So these are the words which I will be using throughout the presentation, and this is what we understand as such. With that, I will start with a quick introduction of the context. So we have two geographical contexts and different people who are linked to that. The most important one is the Greater Paris one. So the thesis was done at IRT System X and CentraleSupélec, so at the Laboratoire Génie Industriel, under the supervision of Flore Vallée, Bernard Yanou, and Sylvie Douzou, with a couple of partners from the private and the public sector. And it was done as part of the Anthropologist chair, which aims to work towards human-centered mobility. There are 4 different tasks which are part of it: futures of urban life and mobility, mobility as a service, future infrastructure, and sustainability. And this thesis is mostly linked to the first task of it. Additionally, and with the motivation to replicate the work which we have done in a different context, I had the great opportunity and chance to have a research visit at the American University in Cairo with Dr. Nabil Moharab and Sherif Gubran. And at the same time, at Transport for Cairo, which is a research consultancy also based in Cairo, Mohamed Egazi and Abdelrahman Melegi as 2 of the key people. So this is a little bit the geographical institutional context. And the structure of the presentation is relatively straightforward. So I want to first start with a little bit of an introduction, say why we are doing what we are doing and so on, provide a little bit of a literature review, present the approach and the structure of the thesis, talk about the design toolbox, which is a central contribution, and end with a discussion and conclusion. And the design toolbox is separated in 3 parts. First, I will talk about it generally, and then afterwards about the case of Paris with a focus on the methodology, and the case of Cairo with a focus on the content. To start with the introduction. So why urban mobility? Why is it important? We are living on a planet which is mostly urbanized. Today, already more than 50%. Until 2050, more than 70% are expected to live in urban areas, which is great in one way, but also leads to a lot of emissions, a lot of other issues, exclusion, and so on. So urban mobility is a central element which defines how we live, where we live, and so on. At the same time, the question is, how can we define it? We can define it from many different disciplines. 3 major ones are urban spatial planning, behavioral changes, and product service design. So behavioral changes could be, for example, a nudge from a metro organization which tries to make people use 2 metros together instead of changing to a car or whatever. And finally, we want the objective behind is sustainable urban mobility. And this is defined as on the environmental side, low to net zero emissions, but also at the social side to have a distributed accessibility. So wherever you live, you should have access to basic opportunities, and also enabling efficient mobility from the economic perspective. The reason why this is important can be divided more or less into 3 same elements. It's the environment, social spatial justice, and the economy. Just to give an example from the environmental side, for example, 10% of global emissions come from urban mobility by itself, about 25% depending on the region from transport in general. The electric vehicles, for example, require a lot of rare materials, so there are a lot of demands from the environmental side. The exclusion part, I talked already a little bit about. The idea of the urban area is providing access to opportunity. That means jobs, education, healthcare, public services, and so on. And finally, on the economic side, one of the major elements there is the loss of productivity due to traffic congestion and so on, but also negative health impact. So in many countries where the air pollution is very bad, for example, it has a very significant cost. To summarize it a little bit, we take the SDG 11.2 of the United Nations Sustainable Development Goals, which says that by 2030, we need safe, affordable, accessible, and sustainable transport systems for all. And for all is further defined at vulnerable groups such as women, children, persons with disabilities, and older people. So this is the larger motivation. On a more methodological side, we have the challenge of very large local diversity. So here, for example, you see Rue de Rivoli in Paris. Then you see the plateau, I think about a year ago, under construction, and you see a street in Cairo. This is, of course, extreme examples, but there's a huge diversity, different people, different needs, different spatial dynamics. So how can we respond to that? That also includes climate, rain, sun, and so on. The second one, and I will be talking mostly about that one, is future uncertainty. So we don't know what is going to happen tomorrow, which means more or less we don't know how many people will live, what they want to do, and so on. We can make anticipations, but there is a significant uncertainty, and that impacts projects which are done today. So for example, if you talk about a standard product or service, it might take 10 years from the ideation to the moment when it enters the market, and then it is planned maybe to continue for 20 years, or in the case of a metro, 20, 30 years. So the question is, how can we prepare for that? And the final one is resource constraints. So whatever we want to do, we cannot do it with unlimited time, unlimited money. So the question is, how can we do that? And how can we try to bring these 3 together? That summarizes a little bit the justification behind the work. The motivation is that we wanted to create practical tools and methods that can support design processes, both public and private stakeholders. We wanted to advance the scientific interface, let's say, between foresight and design in the context of urban development, urban mobility especially, and also advance the systemic understanding of urban areas. And the initial research question behind was how to integrate uncertainties in the design of mobility solutions for urban mobility systems. Uncertainties is another word which will be used throughout, and it refers primarily to everything in the future which we do not know. So we talk about trends, which are things which we assume to happen. So for example, the population growth. Uncertainties are things which we do not know in which way they will develop, but which will have a significant impact. And then finally, the research approach. We use the grounded theory approach with different iterative steps moving between theory and application, most of the 2 application cases. And we try to keep a close link to reality through very close collaboration with stakeholders from the academic field, from the public sector, from the private sector, through field visits, and so on. That brings me to the second part, the literature review. So when we started, we looked at 3 main topics. The first one is sustainable urban mobility in general. And for that, we looked at urbanization. So I've already mentioned before, there's a tendency of more and bigger cities around the world. there's an urgent need for sustainable urban development. Urban mobility is a very critical element within, because it provides the access to opportunities within the city. It has huge impacts on the environment, on the well-being, and so on. And at the same time, there are many global developments, such as the digitalization, localization, and other things which are impacting urban mobility. So this is, let's say, the broader context. What we identified from that is, well, there are a lot of solutions, and we mapped many of them which are existing. We have a lack of systematic and localized uptake of people-centered, local, and sustainable solutions. So it looked a little bit more or less to say, we knew what the problem was. We knew that some of the solutions were there, but we didn't know how to implement them. So this is one of the gaps. The second one is the high degree of future uncertainty and the question how we can integrate this in a structured way in these processes. The second topic of the literature review is on foresight. So this was the second part on futures, on uncertainty, and so on. And it was clear that the future uncertainty is a very significant element. We need to consider it. And there is a field of future studies and foresight, which has very established methods, which, however, are scenario planning being one of the most common ones, but which are used very, very little in actual practice. So we identified two gaps. The first one is a very precise one, as we were lacking a coherent visualization of different concepts from future studies, which I will talk about just in a bit. And the second one is more about how can we apply, how can we use these approaches, but also how can we facilitate this process, for example, through evaluating the efficacy of scenarios to make this process more efficient. The third part is on the design perspective. So we started with the notion of human-centered design, which evolved into people-centered design. The idea behind this, more or less, we have different types of people we want to look at. We look at the user human, the person who is exactly using the mobility service, people who are directly affected, for example, people who will have to deal with the consequences on the streets. And we have distant human, which refers to people who might be affected by the environmental impacts in 20 years from now, or people who are living in a place where the resources are mined for the forest. And then we have stakeholder society, people and humans. And so this is, let's say, the broader context of people-centered design, because what we want to do is look at the different types of people who are involved and who are related to it. The second one is the mobility solution design. It's, as I introduced before, there are a lot of different sectors coming together. You have policy design, product service design, and so on. How can they, in a multi-sectoral approach, be combined? And the last one is that there is this notion of future uses, but it has been very little, or has received very little attention so far, and we wanted to see how we can advance that further. The research gaps in this case are the lack of consideration of people across time and space as introduced, and the approach to combine different models of urbanites. In particular, what we focused on was personas and synthetic populations. I'll introduce them more in detail later, but the idea of personas are that they are archetypical representation of user groups within the society, and synthetic population, and they might primarily used in the design context. In synthetic populations are more from the quantitative side, from the simulation side, used, for example, in agent-based mobility simulations. This led us to one key research question and a couple of supporting questions. So first of all, how can we design processes of people-centered mobility solutions for future urban systems? How can we support them? In order to respond to that, we looked at how we can model urban mobility systems, how we can model them in the future, how we can model future urbanites as one of the elements thereof. And then we repeat the question just to make it a bit more interesting. So ignore this one. Then we look at how can future scenarios be localized. So this is then more looking at the more methodological side. How can the future uncertainties be integrated in synthetic population as one very particular contribution? And how can future uncertainties be integrated in simulations at large? This brings me to the third part, a very short one, just to outline the approach and the structure. So we are building on design research methodology, a simplified visualization, where you have research clarification, descriptive study 1, descriptive study 2, with different objectives. it's not a singular turn, but it's an iterative step which always goes back and forth. And the objective, more or less, is to understand what the motivation is, understand it, support it, and evaluate it. And even if it's not the case for every detail, but in general, we have a little bit the first case study of Paris, which was the descriptive study 1. Then we had different models and support tools which were developed. And finally, there was the evaluation and replication in the case of Cairo. As mentioned before, we tried to be as collaborative as possible throughout the process. So we had a number of interviews and workshops, primarily in France for the first 2 years, then a little bit in Cairo at the end of the second year, and finally again a bit in Paris. And just to give you one example, so this was a workshop we had end of November, nearly 1 year ago, in Cairo, at the American University. And we had a group of mobility experts, a group of urban planning experts, and we tried to localize uncertainties and trends in the context of Cairo. So this is an excerpt from the map of central Cairo. And we tried in each of the workshops to see how different things work, how different support models work. In this case, we tried 2 different orders. So this is where you see 2 different layouts of the visual support. So the workshops at the same time were to collect data, but also to test the models and the support which we developed. Strategic pause. Then we come to the design toolbox, and this is the section I will spend most time on. This is more or less the key contribution, which is constituted of different elements. And as introduced before, I will talk first about it in general, and then focus on the 2 different case studies. By toolbox, I tried my best to visualize the toolbox. As you see, it has not succeeded very much, but the idea is more or less, there are many different tools, methods out there which are used because urban mobility system design is a very broad field. We do not say that there are not already a lot of methods which are out there, but we identified a couple of needs and we tried to add to this toolbox a couple of new things. And the overall objective was always, on the one side, integrating uncertainty, but not just that, also in the context of people-centered design, so approaches which look at individuals and their different needs. And 2 potential uses which we see for such a toolbox are simulation experts, which are trying in their simulations to integrate future uncertainty, or local authority trying to evaluate rapidly the impact of a potential solution. So it's just 2 examples, but that's a general idea. We put a couple of things in that, or we added a couple of things in that toolbox. I will talk about them in detail afterwards. But the idea behind it is more or less that we have this 3 different sections. So we have the drawer with the urban mobility system model. We have the element of futures or future scenarios in particular. And then we have a couple of more precise methods and tools for the future urbanite, the people-centered perspective. And I will talk about them in general first, and then I will focus on the 2 case studies, Paris for the development and Cairo for the replication. And it will most of the time be in the upper right corner. So if you get lost at some point, you can look at the upper right corner. The first research question is on modeling urban mobility systems. I don't want to get too much into detail of that, but the urban systems have been used as, or have been understood as complex systems from the 60s onwards, let's say. So Jacobs and Forrester were 2 of the early people who have been trying to see, okay, how can we model, how can we better understand urban systems? A bit later, it was also understood as systems of systems. So you have the urban system in general, then you have the urban mobility system within, you have the energy system, you have the housing system, and so on. And then there are many very well-established processes on complex system modeling. So we try to take a bit inspiration from the different ones to look at how can we understand urban mobility as a multidisciplinary concept. This is a visualization of a little part of the city. And what we tried, this was done through a couple of experts interviews and tested in different workshops afterwards. We wanted to see what are the elements which impact urban mobility. So land use, for example, means what kind of uses are in which place. Is it only housing, or is it housing and shopping and so on? Urban logistic means delivery and so on. You have public transport, you have active mobility, you have the people. So there are different components together. When we try to organize them a little bit, we can put them in 3 boxes or in 3 layers. The first one is people and active mobility. So that refers to the people, people dynamic, or the people dimension, which includes individual behaviors, social practices, and so on. Can be many discussions about the details of that, but generally there's this group of things which are around people. The second one is services, any type of service, any kind of provision of mobility, may it be urban mobility, public transportation, or new modes of mobility. And then there's the infrastructure, which is mostly the built environment, and the digital infrastructure, which is underlying. All of them interact. The way we try to simplify in order to have a little bit of a system within is that, first of all, people are in a certain place, and the fact that they're in a certain place defines where there's infrastructure. If there's no people, there will be no road in the optimal case. It's not always the case, but theoretically there are people, thus there's infrastructure, and thus you try to connect the infrastructure and the people, or the different elements of the infrastructure, thus you have services. So this is a little bit the logic we follow. I'll come back to that in a bit. Then we tried to take this general understanding of urban mobility systems and add the futures perspective. So the reason for that is, on the one side, the uncertainties which are already introduced. On the other side, the notion of weak problems. Weak problems referring to problems which don't have a singular solution. So for example, if you have COVID, you want to get rid of COVID, that's a simple objective which is behind, but urban mobility, you might have everybody agree that it shouldn't emit resources or shouldn't emit CO2, but it is very difficult to know what the objectives behind are about accessibility and so on. So weak problems and super weak problems refer to issues where then you have also a lot of different stakeholders, different interests, and very little agreement. This is let's say, the challenge about the future, because we cannot define one future where everybody wants to go. The second one is, let's say, the core of future studies. The future cannot be predicted, but alternatives should be considered. So we do not know what is going to happen tomorrow, but we should think about it. And then there are a lot of foresight methods, and scenarios was the one which is, on the one side, the most applied, but on the other side, also the most adequate to respond to the needs of our research problem. To understand a little bit the concepts which are underlying, we mapped key concepts of future studies, such as, for example, linear temporality, meaning we go from today to the future. We don't assume that we go backwards or whatever. You have a widening range of possibilities. That means today we know where we are more or less, but we don't know in 5 years, and in 10 years we know even less, and so on and so on. And these are concepts which have been already integrated in existing visualizations, which I will show just afterwards. And then we found a few other ones in literature which haven't been integrated so far. And this led to an updated visualization of the futures cone. You see the previous version in the upper left corner. So the idea of the futures cone is more or less to make concepts of future studies tangible and provide a basis for discussion. So we are here today, and let's say 2050, we are here, and we can define which futures are the most probable, or we can try to define which are the ones which are plausible, possible, and also which are the ones which are preferred by a certain group, depending on certain criteria. So this is, that was, let's say, the conceptual framing, and has been published and used thereafter. The reason I show it here in particular is because these things you see in the little and in the end, the small circles, this is what we refer to with scenarios. So it's a set of, to repeat a little bit the definition from earlier, it's a set of possible, plausible future alternatives, which are distinct from each other, normally have a narrative, so they're not just quantified, and exist always in a set. So we cannot have one scenario, we always need to have at least a couple of them. This is the full version with a couple of more details. The question is then, if we want to understand how we get to a certain scenario or to a set of scenarios, what happens in between today and the future? Now I come back to trends and uncertainties, which I briefly introduced earlier. Here shown for the case of Paris. So trends are anticipated future developments. We are very certain that they will happen. Population growth is still ongoing in many places of the world. Aging society, at least here, is the case. The Metro 18, for the people who know the Paris case a bit, it's very likely that it will be there. It's nearly done. So whatever we do, whatever we think about in 2030, we can assume that this will be the case. On the other side, there are a lot of uncertainties where we don't know what happens. And critical uncertainties in particular are those which have a very high anticipated impact. So the question is how we can look at them, how we can use them. That can be, for example, car ownership, how many cars per people will be there, what are the preferences of users, what is the density, and so on. So two concepts which will reappear several times. Then if we take these two concepts together, the scenarios as part of a way to look at different possibilities of the future, the urban mobility system with its different layers, we put them together in a framework which has on one side the scenarios, here with some examples of archetypical scenarios from the urban mobility sector, and then the three layers of urban mobility systems in the order as I described before. First their people, then their infrastructures, and then their mobility services. And then we can do different things with it, such as, for example, evaluating the impacts of different scenarios. Then another side project which we had was on trying to find out how we can make them more accessible, which is the quality assurance, but I will not talk about it during the presentation about it today. Third part is the people-centered perspective. So how do we model future urbanites? We go back to the concept of personas as archetypical representations of homogeneous groups of people, initially developed by Microsoft in the beginning of the 2000s in order to adapt their products to different groups. Then an evolution, let's say, towards future personas in order to integrate trends uncertainties, and synthetic populations used in simulation and quantitative approaches to model groups of people in a statistically representative way. When we look at people, we can look at different things. We can look at basic characteristics, such as age and gender preferences. For example, how much do we value 1 minute of our time? Different constraints, are we able to walk very far or not? And resources, do we have access to a car, a driving license, and so on? And then we model them in two different ways, here in personas and in synthetic populations. In the upper right corner is an example of a persona card, which was used in one of the workshops. And what we tried to do in this part more or less was look at the framing of futures. So the future scone as a way to visualize and communicate future studies concepts, having an urban mobility system model, which is sufficiently actionable in order to integrate it in design processes, and having a combination of models to represent people, notably personas and synthetic populations. And some potential perspective for future work I will talk about further later, but it would be extending it to other urban systems, for example, or using the urbanite model, which we started with two of the methods, persona synthetic populations, and other methods. Now we'll get to the first case study, which is Paris. So as a quick context, you see the region Île-de-France in orange. You see the city of Paris in the center in dark blue. You see the Métropole du Paris, and you see the inter-council partnership, the l'agglomération de communauté Paris-Saclay, which was one of our project partners. So our focus was mostly on the yellow part, but people don't stay within. So I think many of you, for example, live outside of this or go outside. So we look more at a regional scale, of course, with a focus on the inner Parisian part. To understand the mobility dynamics here. We took the developed framework and we wanted to test it in two different fields. One, adding uncertainties to agent-based simulations, and then adding uncertainties to design support processes, in particular one tool. Starting with the first one, it's a 10-step process. It has just been accepted for publication 3-4 days ago. So this is a very detailed process, more or less, how to integrate uncertainties in one of the inputs which are used for agent-based simulation, notably the synthetic populations. I'm not going to talk about all the different steps, but just try to outline the key elements. We took a couple of urban mobility scenarios, in this case, archetypical mobility scenarios for 2030, which were developed by Ms. Goldsky and all. From the old transport, we continue as things have been. At an easy pace, we transition a little bit as we have been doing in the last years, minus years, talking about sharing, mobility as a service, and so on. and tech mobility, let's say autonomous vehicles and other kind of technological solutions. Then we look at different trends. So trends is, let's say, the population growth, but we also look at uncertainties such as changing car ownership rates, proximity to work and school or household size, and see how we can integrate them in the simulations. So here you see some examples of, for example, an increase of 5% under 2030, a decrease of 10%, and so on. In order to do so, we focused on the people dimension, and we took census data and urban mobility survey data and clustered them to create 16 proto-personas. Proto-personas referring to, let's say, the origin of, or the predecessor, I don't know if that's the right word, for personas. So a way to say, okay, these are the key criteria of information, and then they can be enriched afterwards with more qualitative information. And it's a particular way of clustering, but the idea is more or less trying to find from all the people who are in the census, who are the most similar across multiple criteria I think about. And then in order to match the different uncertainties, for example, the car ownership rate of 0.88 of today. In scenario 1, we want it to be 0.8, in scenario 2, 0.87, and so on. So there are different multiple uncertainties, in this case 3. And through iterative proportional fitting process, we looked at how many personas more do we need of one group compared to another in order to reach the synthetic population which integrates the future uncertainties across the different scenarios. This led to two different, say, design inputs. On the one side, we have the enriched proto-personas, so the proto-personas being only quantified information. And then we can add information such as a name, a little bit of a story, a photo, and so on to make them more tangible for our qualitative design processes. We have them for today and for the future. And at the same time, we have the synthetic population of today built on existing methods, and then the variation of the synthetic populations for different scenarios of 2030 through the process just introduced before. We use that afterwards to simulate the urban mobility system at the Ile-de-France level, which was done in collaboration with Tjark Gall and Sebastian Höhn. So we looked at the present situation, people, services, infrastructure. Then we looked at 4 different scenarios, the changes between today and the future, where we integrated trends. Trends being population growth and mobility infrastructure, which is planned, which is ongoing, and which is supposed to be there until 2030. And the uncertainties through the synthetic population, and then added to each of the scenarios the same kind of urban mobility solution. In this case, a fleet of shared electric automated vehicles, which means you have vehicles which can pick you up from a train station, bring you somewhere, or take you from somewhere and bring you to the train station, to see how such a solution would perform in our context. I'm just going to show a few of the results. This is the CO2 equivalent emissions for all of Ile-de-France, so in the darker blue, and Paris-Saclay in yellow. So we see there's a significant decrease from today until 2030 without the solution and with the solution. So there's a significant difference between today and the future, despite having more people and more cars. But that results because we assume that there's a decrease or an improvement of the efficiency of vehicles. So there's a continuous improvement of the vehicle fleet. So the most significant decrease comes from there. Nevertheless, there is an impact inside our study area and at the larger Ile-de-France area. Can then look at the scenarios to see how the different scenarios perform. So the worst in this case is the tech one, and the best is at an easy pace. So we see how each of them performs compared to the others, and how the new solution decreases the emissions in Paris-Saclay, respectively. And what we can see from that is more or less vehicle improvement is the biggest one. The variations in scenarios is significant. And the solution of the SAEV is the one with the third most or the least impact, say, on the overall emissions, but still significant. The personas become interesting when we try to understand where this comes from. So we have, for example, one of the 16 proto-personas, Céline Dupont, 28. She is representing 121,000 people today, and about 141,000 people across the different scenarios in the future. This is a bit of description. There are things such as he lives in a 4-room apartment. This is information coming from the census, but there are also some qualitative additions. And then we can look at emissions, the distance they travel per day, time and expenses, always compared to the average of 2030. What it shows us is that some people emit much more than others. That's not a surprise, but it allows us to look at it much more in detail. And it allows us also to see, for example, for whom a solution might have the most significant impact between different scenarios or between the implementation of the solution and not. And yes, I think I said more or less this. So we have we looked at not only emissions but also accessibility and so on. I just showed the result from the emissions part. But the most impactful part is the vehicle efficiency, followed by the different scenarios, and finally the solution. There are significant differences between these personas, so the clustering must have had some kind of successful approach, let's say. And it allows us to analyze more complex mobility solutions, which have a lot of interactions and so on, such as sharing vehicles, and estimate impacts, looking at or integrating future uncertainties through scenarios. Then very briefly about the second one, more targeted at qualitative design processes, or in this case, a design support tool, which was conceived a bit with the idea to support decision processes in public sector, such as one of our partners, CPS. Again, a couple of different processes. The idea is to translate complex scenario and persona-based evaluation processes, as introduced before, in a much more tangible tool, which can be used independently or as a step before the other one, or as a step to collect data, which can afterwards feed into the simulations. That was translated into an interactive tool, which is accessible in the internet. And what it permits us, for example, is to choose between different numbers of scenarios. They are pre-filled with standard information, what we can change it with different information. We can say how many personas we want to have, what the characteristics of these personas are. And in the end, we can compare, again, different criteria. Again, it was the same as before, so the emissions, the accessibility, and the costs. Here you see the comparison for 3 different personas across the different scenarios with different solutions. In this case, it's an e-bike which was introduced, and another solution which I don't remember. It's a screenshot from one of the workshops. But this is more or less the idea behind. We validated that in 2 in-person workshops, so it's no completed work, but it's some, let's say, an overall framework which can be developed further. But it showed that it can raise awareness about 2 things, mostly uncertainties of the future, but also the differences of people. And it facilitated at the same time interdisciplinary collaboration, because different people can relate to different elements of this process. To summarize up the part of Paris, so we created a methodology to create a future set of personas in synthetic populations, and also a set of localized scenarios. We evaluated one particular technological solution across future scenarios. We developed an interactive platform, and there are a couple of perspectives. Looking at the time, I'll speak a bit faster. Okay. The second part is on Cairo, so it's shorter. That's a good thing. Otherwise, the focus here is on really replicating the process, and we focused on the first one, the quantitative approach, the simulation approach. It was mostly in collaboration with the American University in Cairo and Transport for Cairo, which are, by the way, there and there. So this is Cairo. This is how we defined it together with Transport for Cairo as more or less the continuous urban area, which is very, very difficult as orientation. The Nile is going through here, and the pyramids of Giza are there. And it's about, I think, 22 million people who are living within this area. We did the expert workshop in Cairo to localize the trends and uncertainties to develop scenarios. So we had what I showed earlier, and then we had a following survey. Just to show one of the parts, we asked different uncertainties, which resulted from literature and interviews. And then we had participants rate them between the most likely and the most important. resulted in two different ones here, and which permitted us to use a little bit easier scenario approach, which is a 2x2 matrix. So we have two critical uncertainties on the x and y axis, one being car ownership, the other one being sprawl. So sprawl refers to the spatial expansion. The more sprawl, the more spatially expanded, and the opposite is densification. So we have two dense scenarios and two sprawl scenarios, and we have one where the car ownership rate increases as it has been increasing relatively stable over the last 20 years before we don't have data. And the other one stays exactly the same, so there are more people, but the same number of cars per person. Then we made a base simulation. So here you see the traffic volume per street segment, which was validated by experts. We are not claiming this simulations to be very accurate, but they seem to be relatively close to what is happening in reality. And we can also look at, for example, different departure and arrival times of different trips of different modes over one day, which is always the time which is simulated. Then just to show how we localize the uncertainties there, to look at, for example, the sprawl intensification. This is the distribution of density across administrative entities today. And then for the sprawl intensification, we adapted them. I'm happy to talk more about it in detail later. In that case, we didn't want to focus on SAUVs, but we wanted to look at what solutions are there which have a potential impact and which are not that costly, and which are currently discussed. And this is once a bus rapid transit, which means a bus with a dedicated bus lane and a couple of other things, as currently discussed for the context of Cairo, or Greater Cairo. And we have improved walkability, which means what happens if we increase the walkability around the station to increase the catchment area of the station, and the intermodality, meaning how can people change between a bus and a train and so on. The motivations for the choice of these things results primarily from work which has been done by Transport for Cairo, where they looked at barriers to public transportation, for example, today, and also by the expert input from the American University. This results in 4 scenarios, 2030, today, and different combinations of the solutions and the base simulation. So each of these as something represents one simulation. This one, for example, is auto sprawl with all 3 solutions together. This one is the urban revival scenario, which only introduces one. So we looked at the individual impact of interventions, but also their combined impact. We can do different analysis. We see which scenario performs better, which combination performs better. But in the end, I don't want to talk about the content too much, but more about the behind. So it permits us to see the significant difference between scenarios. It shows the impact of different solutions and so on. And it shows that, well, sprawl is not the most effective thing and more cars are not the most effective thing, but that was also not a surprise. But let's say that was the idea behind. Can zoom a bit in, look at different criteria which we used, such as how many people use public transport for trips which are longer than 1 kilometer, how many people walk for trips which are shorter than 1 kilometer, how much time do people use, how much CO2 is emitted, and so on. And what we see here is that the auto sprawl performs, so the bigger it is, the better it is. The auto sprawl performs the worst. The urban revival performs the best. The impacts of the solutions in a perfect scenario or in a good scenario are very, very small. So this is the comparison. However, in a relatively likely and not so positive solution scenario, the impact is very, very significant. Which is also a little bit one of the interesting parts. What we did thus in Cairo was we replicated and validated parts of the methodologies. We created a little bit a complementary process of localizing scenarios through the survey and the workshop on importance and likelihood of uncertainties. And we evaluated the potential impact of, or the impact of the 3 potential urban mobility solutions. That brings me to the discussion and the conclusion. So coming back to the toolbox, as a summary, we added the urban mobility system model. We updated the futures cone in order to be more adapted to one thing I didn't mention earlier, it was not that there was one futures cone which was representing everything despite the 3 new ones, but there are many different ones, and we wanted to have one where everything comes together. So there are the 2 different elements. That's the updated futures cone. Together, they end up in this scenario-based framework, which we used throughout the 2 different case studies. This process of creating proto-personas and the link or their use in order to work with different future synthetic populations. The test in Paris, the validation in Cairo. And that's more or less the summary of the different elements. And then to come back to the research question, how we can design or how we can support design processes of people-centered mobility solutions. What we try to do is start with a systematic or structured approach to model the different components. See how we can put that together in a toolbox or in a structured way, more or less, to support the process. Combine different disciplines such as systemic model or system modeling, foresight, a more people-centered approach. And in the end, I think the key contributions are on the theoretical side, more the work around futures and so on, because it was more the theoretical part of the work, the foundational work. And then on the methodological side, it's primarily the link or the development of personas and the link to synthetic population, the integration in simulations and in qualitative design processes. And a very big highlighted part on the way to work with heterogeneous future urbanites, because that was one of the underlying motivations to work towards better urban mobility solutions, but keeping in mind the diversity or the heterogeneity between the population. We do assume that there are overall benefits of the work which we have conducted, but there are also a lot of limitations. So we talked about people-centered approaches. Many times we talk about collaborative approaches. So we did not collaborate in the beginning due to COVID, but also due to other reasons, directly with users. But we focused primarily to work across different disciplines with different experts and also partially the private sector. So this is something which could be developed further. We looked at 2 methods, one qualitative, one quantitative, but there are many others. However, between these, there are always challenges, and we did try to address them, but there are limitations which are inherent between different methods. There's further validation needed of any of these kind of foresight approaches, because we are working with 2030, 2040, 2050. We cannot wait until then to see if it works. So there's a need to develop that further. And then we have limitations in certain contexts. For example, in New Cairo, we had challenges in certain areas, for example, because we try to use the framework which we developed to see how different dynamics work together, but sometimes there are external factors, for example, political reasons or economic reasons, which make development happen differently than it would be in our model case. So I don't want to talk more about that, but let's say the key elements on the other side, on the limitation side. And we assume a certain validity, replicability, due to the fact that we took 2 very different places, 2 different methodologies, but there's also a significant need, but also opportunity for further validation, uptake, and replication, which is partially ongoing. The work has been published in 2 journal papers, peer-reviewed and non-peer-reviewed conference papers, 1 report, and very soon a book which has been created by the collaborators of the Antwerp Wallace Chair together. So it's, let's say, a shorter and more synthetic description of our approach. And all of the work which has been created on the quantitative side, let's say, is accessible in open repositories. And that brings me, I think, to nearly the last slide, which is the recommendations. So I hope the time permits me to do so. I think generally what I learned also personally throughout this was that there's a need, but also huge potential for more methodological approaches to design and planning. So my background is urban design, urban planning. I would say we have some approaches, but maybe it's not always the most structured ones. I think in design science, there are many of those, and there's a lot of potential between the different disciplines to learn from, to integrate it, and also to apply it further. Uncertainty is an incredibly important topic. It will be more so in the future due to climate change and many other things. So there are existing methods, but there are many, many limitations in how it can be integrated. We try to contribute a bit, but there's much more to be done. And when we talk about the solutions itself, and at least in our case, the technological solutions were the least powerful ones, the biggest the biggest impact was by looking at what people do and where people are. So to phrase it in different ways, where do people live, where do people work, and how do they get between the different places, and the technological solutions are just a minor impact at the end. Continuations are different, so we are working on improving different components at the moment. There is the objective to improve further the potential of the interface between qualitative and quantitative urban system futures, mostly by looking at ways how we can use quantitative approaches to integrate into the scenario building. Replicate the work either in different contexts with different solutions and so on. Integrate, so I talked about the different layers earlier, people, infrastructures and services. So looking more at the interaction between people and the other two. We focused on people, and possibly see how it would work in areas such as energy, housing, and so on. And on a more private side or personal side, also trying to see how the methods which we developed can be used in other fields, such as, for example, climate risk modeling, working with different adaptation or climate adaptation scenarios and so on. So this is another ongoing part. These are the references from the presentation, and with that also.